The third topic we're dealing with here is precision spraying, and this is really the application of precision agriculture, or if you like, where we're using GPS position signals to try and help us in terms of our machine control. So what can we do with spraying? Well, really there are three different options with spraying. The ultimate, I suppose, is looking at maybe mapping or looking at areas within a field that need to be treated selectively. And the typical example that we could take, say in Ireland at the moment, would be to look at the sterile brome problem that we have. The sterile brome problem is normally located in very specific, or starts off in very specific areas of field, particularly when you're ploughing. It's on the headlands or where the plough meets the headland area. What we could do is we could map those areas, either by using possibly a drone to look at them at a particular time of year and physically marking on an electronic map, putting a marking system on that which shows the area that has the problem weed in it. And then we come along, we put that map into our sprayer controller that's GPS enabled and only spray the areas where the weed is there. So in that situation we might be only spraying maybe 5 or 10% of the field, and we could stop sterile brome being an invasive problem in that sort of field. So there are opportunities to do that, not being practiced much at the moment, but the technology is there to help us to do that, and that will become more common in the future. The second one is, second scope for using GPS and precision agriculture in spraying and spraying operations, is to use it to create the actual tram lines. In other words, to use an auto steer system and a high accuracy GPS to give us very accurate tramline distances. We normally use tramlines today that are set mechanically by the seeding operation. In other words, the drill comes into the field, sows maybe a 3-metre pass, and has a scribe mark that his next pass is meant to be 3 metres away. But of course we always build in an overlap into that system. That overlap gives an error. The error is often maybe in a 3-metre unit about 5%, 150 millimetres in that error. That means in a sprayer width, if we're adding 7 of those passes to build up a spray width of 21 metres, the error is actually a metre. In other words, the sprayer is overspraying by approximately a metre in that situation. We can eliminate that by actually setting the tram lines using an auto steer system on the spraying tractor and not actually put in the tram lines before that at all, and we can eliminate that error. The problem is the auto steer systems can be quite expensive, so we really need to be able to justify that cost. If you cannot afford to do it by that method, well then you need to be braver with how you mark, how you set the scribes on your drill to make sure your tram lines are actually at 21 metres, or indeed to turn off a nozzle or two in your sprayer so that you accurately match 20-metre tram lines if that's what you effectively have. That's the second option on GPS. Moving to the third board here, third and most common use of precision agriculture in terms of spraying is used for what's called auto section control. When a sprayer meets a headland, the sprayer actually has to be turned off at the right point, and this can be very difficult to do on a modern sprayer with a very wide boom, particularly on a trail sprayer where the boom is back a distance from where the operator is sitting. So it's hard to accurately do that. And sprayer booms can be turned off in actual sections, but again it's very hard to match those sections properly, and we end up turning off maybe a little bit late or a little bit early, and we end up with areas that are not sprayed at all or areas that are oversprayed by an excessive amount. But we can use our GPS controller to do that. In other words, with the properly enabled sprayer, the sprayer can map where it has previously sprayed on the headland run, and we can actually see that in the field today, that we can see this operator where he is actually doing, first of all, it's coming down the field, marking his headland operation, and then when he turns back, he's going to cross into that area again, an area that has already been sprayed. But the controller knows where the sprayer has been before and starts turning off the sections as they overlap the previous section. And it does this much more accurately than an operator would do it himself, because it knows exactly where the position of the boom is at any one time, and starts turning off each of, in this case, the 8 individual sections precisely at the right moment when it has fully covered the previous run. There's one section switched off. He's going across second section off. Third section off. So when it's measured that it's actually overlapped, it turns off the section automatically. What it saves depends on the size of the sprayer, the shape of the field, and indeed the skill of the operator. But in some American work, the savings made by automating this process using GPS have shown that depending on field size, the savings can be between 2 and 20%. I would think in an Irish context, it's probably at the lower end of that, between 2 and 5%. So you have to work out really whether it pays in that regard, but on some situations it certainly will pay to gear up to make that saving.